Hi, welcome to day 7 of Advent of Code 2025, and let's start. So, I had already taken a look at the task and what it asks is, given this kind of map, we have beams that beam down from the starting point S. They always beam down, but when they encounter these splitters, they actually split into two. They go from here and from here from this point. So now there are two beams that fall down, here and here. And again, it happens again. And so they ask us, how many times do we have to split the beam? And yeah, this is an illustration of what's going on. Beam falls here, it splits in two, it splits again. You also have to combine the beams, so you cannot count this as two beams. That's a big detail. This process continues until all of the tachyon beams either reach the splitter like this one or exit the manifold, basically here, like this. To repair the teleporter, you first need to understand the beam splitting properties, blah blah blah. And here it is split 21 times. How many times will the beam split? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20... Wait, what? 3, 6, 9, 13, 16... Wait. Ah, yes, this one does not receive any beams, so it's excluded. So every splitter receives a beam except this one. So it's 22 splitters, but only 21 splits. So analyze your manifold diagram. How many times will be split? Okay, let's go. Day 7. Example txt. Let's get the input. Let's create the project. Let's open the project. Let's do the usual boilerplate. Not example, input here. Static str. Let's write some tests. Let's do an example here. Let's do a test. Let's do solve 1. Actually, let it be like, let's say it's to do. Let's say that we have a test solve 1, and let's say that the solved example should produce 21. If I run this test, then it fails, and all I have to do is unfail it. Done! No, I'm joking. Okay, now let's solve it properly. So, first of all, this looks very much like DFS. Basically, we have a graph of beams that is directed acyclic, and it's not actually a tree, but it's acyclic. So it's a deck of beams. And now, so question number 1, where's the starting point? Question number 2, do a DFS, do not repeat already, do not beam from already visited places, from already beamed places. Count all structures. Okay. Okay. So let's have our grid. Let's say that this is a vector of bytes made from, let's say like this. Actually, I really don't know this capacity yet, but yeah, this is a good proxy as length. Now, yeah, type annotations needed, definitely, but not right now. So, what happens next? Let's do some constants. So, first one, empty is not a character, but actually a U8, which looks like this. Next thing, beam looks like this. Start. Why do I write this down? Is S, yes, it's uppercase. Const split. Yeah. Okay, now let's go through the lines as lines, and let's enumerate them. Okay, start will not be used much, so it's okay to write it down completely. Let's write some explanations with a grid. Okay, so the start is at Come on. Okay, I don't care. Use size max, use size max. I don't care. Now, okay. Yeah, lines enumerate if line as bytes contain. Okay, yeah, let's do a conversion. Byte line. Okay, this is getting ridiculous. Yeah, let's just convert it as it is, as bytes. If line contains start, then start becomes, oh, I also want to know the position. Come on. Okay, yeah, I think I need to find how do I find the index of an element? Oh, do I have to do it in the stupid way, like line, iter, enumerate, find, j, c. Come on. C is equal to start if let's j, then start becomes ij, right? And let's answer our question. Start at ij. Oh no, it's not an expression. Yeah, but that will do. No, start. Okay, this needs to be debug print. Yeah. So, where's the starting point? Let's also populate the grid. So the grid is extended. Is this some kind of AI shenanigans? It tries to guide me into using a slice. Whatever. Okay, what do I do? Yeah, I extend it from here without the new line. What's on here? Expected tuple found ref. Okay, so what's the type of find? Option self item, and self item is, yeah, I agree. Yes. And now what's one? Oh, you copy it? Actually, I don't care. Oh, Rust, really? Please stop. Rust, come on. Now what? Are you happy now? What am I even doing? No, I'm pretty puzzled. What am I even doing here? Are you happy now? Are you happy now? Are you happy now? Okay, putting ampersand and stars until rustc is happy was not a joke. Okay, now it's extended from slice. Let's mute. What do we need to know? The title of it, and let mute n is 0. So each time there is a new line, m gets incremented, and if n is 0, then n becomes line length. Else, if n is not equal line length, we panic. That line, add line size, line, not n. Okay, that's fine too. It is ASCII, so that's fine. Okay, let's rerun the test and see what it outputs. Start at 07. Is this correct? Example. Yep, 0. Wait, 0. 1, 2, 3, 4, 5, 6, 7. Okay, I assume it is good. Yeah. Now, did you determine the grid size correctly? 16, 15. Grok, is this true? 16? Uh-huh. Is it 15? What the hell? I was just trying to highlight this line. Ah, yeah, okay. Okay, yeah. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And here it's, yes, it's 16. Okay, I think this checks out. Let's do the next part. Now, we do have our grid populated, we know the starting point, and now we have to do a DFS. And DFS means that we have to keep track, that we have to do a stack that keeps track of new beams that we delayed, that we have to beam later, but we haven't beamed yet. And that will look like what? From iterator, from one element, the start position. Okay, and then we just visit it from some position, stack, not poop, pop. Okay, let's say that there is some cell below, which will be grid get oh, actually, let's do it like this. I plus 1 and j, else if we fall, then we fall what was the word in there? Fabricator. Okay, now let's reference it. And now, so if it does fall out of the fabricator, then there's nothing we can do with it, and we continue, and we beam other places. What's wrong with you? Oh, right. Oof. This crap again. Multiplied by n plus j. Okay, that makes sense. Now, so if beams combine, then we also continue. So actually, I could even do it like this. Match this grab with none. Continue. Some beam. Continue. And it should be cloned. If it's an empty place, then this place is not empty anymore. So grid let's rewrite it like this. So grid at P becomes a beam, and stack push P. Does that make sense? Yeah, I think so. If what else can be there? Yeah, if we fall at start, that means that the geometry of this thing has been broken and it's not a Euclidean surface anymore, and we don't care, and actually, yeah, it's just plain panic. So yeah, if we see a split, then then it becomes interesting. What happens when beam goes? What happens if splitter is the wall? So is the split beam just lost? For example, if it happens to be here, does it just emit one new beam on this side and this one is lost? How exactly is this handled? Side wall. Oh yes, it's a good question. It looks like an ambiguity. Are there any hints in the wording of the task? Mm-hmm. 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 So, what if there is no immediate left or and right? Does it wrap around? Is it lost? Yeah, I don't know. Let's assume that it will be lost. So, P1. This becomes I, j minus 1, or not. Yeah, let's just check it in this way. So if j minus, oh, okay. If j is 0, is more than 0, then we can push a new position at I plus 1 and j minus 1. If j is less than n minus 1, then we can push I plus 1, j plus 1. Okay. Is that it? What happened here? Oh, yes, I just removed it. And if there is any other cell value, then we panic. Bad cell at let's not mix it. Yes, and this will be a debug format, and the cell will be here. Okay, let's maybe visualize the propagation. Oh, yes, and here it gets funny. If I kept the new lines, then I could easily visualize it, but now I cannot just cast it to a string and print it. Okay, yeah. I don't mind. But now all position calculations are a little bit off. Basically like this. But fortunately there are not many position calculations. Okay. Oh. Yeah, I see. That must be I plus 1 j. Yeah, it falls down. Beam down. Beam from left. Beam from right. And let's visualize. So str from fade unchecked. Yes, you only live once. And I print the grid. Takes a reference. Oh, yeah. And this must be reference to. Yeah. So, what happens? I very much hope that it will not get stuck. Oh, so it actually produces slightly incorrect drawing. So yeah, let's fix that. Yeah, that was incorrect. Will the drawing be correct? No. I think so. Yes. Now, after propagation is done, count all structures like this. So basically, for I in to M, for J in 0 to N, let mute result. B. Skip the new line. And here +1 if grid at P match grid at P, grid get P minus N, the previous line, and -1. Yeah. So if we match with split and some again cloned and some beam above it, then result is incremented by 1. Any other case, continue. Yeah, I could split it, but I could just rewrite this as an if, but yeah, that's good to know. And let's also say something like no, let's just see if it works. It doesn't. Yay, now we have to debug. Attempt to subtractors overflow here. Oh, yes. Okay. Okay. N+1 and GP is equal to a split and GP minus N minus 1 is equal to beam above it. In this case, this happens. Otherwise, sure, go away. Okay. And now it seems to work. Let's write down the assumption here. An assumption beam is lost. If no error on this on a side. Okay. Now the moment of truth. Cargo run. Oh. Is there any nice drawing in here? Yeah, it's just a New Year tree. Let's try that. Yay. Continue to part 2. With your analysis of the manifold complete, let me just read it. Shocked Pikachu. With a quantum tachyon manifold, only a single tachyon. Mind blown. It actually times itself, which split in one time the particle went left and the other. Truly need the number of timelines active after. Okay, my brain hurts a little bit. Let me have some tea. Oh, I see. Okay, so the twist seems to be that now we cannot just look at the state Okay, I still don't understand it. Okay. At the same point at the alternating timeline, but takes a totally different path. I wouldn't say it's a totally different path, but yes. But it's different. In this example, in total, the particle ends up in 40 different timelines. So Why is it 40? Huh. Is this just a DFS now, where we increment each beam that is lost? Can we say that there is a property that the number that we calculated previously is somehow related to the number of possible timelines? So if we know that 21 splitter was hit by a beam, mm, that means what? So this splitter, one splitter that was hit by a beam, actually creates two timelines, right? This one also creates two timelines. Oh, okay, I see. So this one does create two timelines, but in each of these timelines, uh, not all splitters. Mhm. Not all splitters participate in this timeline. So after beam came here and two timelines were created, in one timeline it's as if only this was a starting point. In another timeline it's as if only this was a starting point. Oh, okay, okay. Now it actually looks like a dynamic programming. Hmm. Hmm. So, is my assumption correct that mm, each splitter that was hit creates two timelines? Hmm. Mhm. So, if I trace this back, so I did a propagation down. Now I know that the beam fell here, the beams fell here. So we know that in all possible timelines, beams fell here, 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 and here. Then if we wind this back, then these beams come into contact with the splitter. Ah, that's why tachyons, because they travel back in time. Yes, 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 that was the hint. And this one propagates here, and it's also interacts with, in one reality, it interacts with this splitter, in another reality, it interacts with this splitter, and interesting. So this one, hmm, this one takes part in at least two realities. Well, each one takes part in at least two realities, yes. Oh. Okay, so if we have a reality, I see. So, uh, previous number of realities multiplied by 2. Previous number of realities multiplied by 2. Uh, Previous number of realities multiplied by huh. So two realities coming from here, two realities coming from here, but only three realities coming from here, originating from here. Two realities originating from here, but two from here, but only three from here. Okay. Um, 3, 3. Okay. So, four realities and three additional realities. So, wait. But it's a shared reality. Or is it not? 2, 3, 3. Okay, four realities, four realities. Oh. Wait. Wait. One reality, 2, 3, 4. Aha. Aha. So, splitters at this level are just like binary, are like the least significant binary digits. Splitters at this level are like hmm, mhm. Yes, this splitter works as an additional. binary digit, right? Oh, yeah, my mind is blown. Okay, what happens in this case? This one. There is one reality, 2, 3. So, if there are so there is one reality on this side and two realities on this side, and in total it's 3 realities. Here it's 4 realities, 4 realities. This one, what happens here? It's 4 realities on this side and 1 reality on this side. It's 5 realities. This one is 2 realities. This one is four realities and 1 5 realities. Okay. That becomes mind-blowing. But I think the principle still holds. So it's just easier to calculate now at this point that yes, let's just backpropagate. So the one reality, one reality, one reality, one reality, two realities, two realities. Yes, I think that's it. Yes. Let's try to calculate it. Okay, let's reorganize this a little bit. Let's say that parse produces a vector of produces a use size vector of u8. Okay. And in the end, we return mn and the grid. Grid oh no, it's and grid parse what? Parse s. Okay. Does it still make sense now? No. Oh, start. I also have to return start. So this is the size, this is the start, grid, size, and the start. Structures could be so much better, but yeah, whatever. Start. And what it returns is, let's just do very lightweight types. And let's say it's vacuate, pause. Good. Now, I can say that the grid is here, m and n are here, and the start is here. Yes, it works. Then the next thing, 19, 21. The next thing is fan propagate. So I take this, take a grid which is a reference to u8, the start position, which is a position, And yes, it's a mutable thing, right? Yes, I think so. Now let's say that propagate reference to a grid, mutable reference. As mute slice, right? Yes. And count. Let's change this. I don't know. It's specific to this. So 1. So there is no point in actually doing this and separating this into a helper. Okay, fn solve 2. So again, we take this thing and we return a U64 of possible timelines. And so far it's to do. The first thing that we do is we take a grid, its size and the start point, and it's parsed from the string. Next thing is yeah, let's propagate. Why does it not work as slice? And then we are left with this nice to do. Now let's draw the rest of the order. Okay, let's backpropagate. Let's say that we have let's say we have the front, which is a hash set of positions from which we backpropagate. Let's also have realities, which is a vector of reality counters of realities. Let's say it's made from an iterator of iter repeat 0 U64. How many times? M by n? Yes, I think so. Yes, now let's start from the last line. From 0 to m reverse. What do we do now? For j in 0 to n, match grid, let p is by m plus 1 plus j, right? So if the grid at position p is equal to empty, then don't do anything. If it's equal to a beam, then take propagation means that we should look down and we should cache the number of reality. So if there is no down, then it's just one reality. A beam was at the lowest point. Actually, let's do it like this. So for j in 0 to n, let's go over the last line. Let's say let mid p is equal to m minus 1 multiplied by n plus 1, and while p, let's not overcomplicate that, in 0 to n, so now let's match g at p with, if it's empty, then do nothing. What else can be there? If it's a beam, then set the number of realities m minus 1j to 1. If there is a splitter at the last line, that means very simple thing. We write to do and do it lazily if we need to. Okay. If the start position happens here, then I don't know, to do as well, because whatever. Panic. Bad cell. Whatever. If I really need to debug this, I will. But right now, I only need to do this. Back propagate realities. Everything everywhere all at once. Okay, if we came to the start position, that means that we have to look at the position below it and take the number of realities from there. Then gp becomes, just return the number of realities at here, right? If we see a beam, oh come on, just propagate the same thing. So basically rs p becomes, it propagates from -1. What was front again? Why do I care about this? Yeah, that was just some LLM talking in my head. Okay, beam. What else? Splits. Yeah. Empty. It's okay. Panic. Well, let's even say it's unwishable. So whatever. So if we encounter a split, that means that we should add the number of realities at I plus 1, j plus 1, and I plus 1, j minus 1. Basically, that becomes something like p minus n plus s p minus n minus 2 if it does exist. So basically, this always exists because it's not the last line, and n minus 1 must exist. Here, it's not it must exist too. But here, this one might not actually make sense. Oh, come on. So I do have to, yeah, it's not overcomplicate this. Let's give up and use vector refactors. Work from iter or iter repeat with vec new vec with capacity of come on repeat 0 0 n times, yes, and this one repeats endlessly. No, I don't want it endlessly. Oh, come on. Oh, that's fine. That's actually fine. I can repeat it. But I just need to take it m times. Yeah. And that, I think that will do. Okay. And let's say this explicitly, that this is a vec of u64 counters of realities for each cell. No, this becomes nonsense. Which is a good thing. This becomes, so what did I want to say here? I wanted to say that we replicate the number of realities one position below, yes, and if it was a beam, then we replicate at ij the number of realities from down below, and in this case we try to get I plus 1s row. Okay. Realities 1 is rs get this. If it exists, then and then get j minus 1 unwrap or 0. Come on. Now let's repeat the same for, yes, for next line, and plus 1 or it's 0, and let's say that this is combined number of realities on the left and on the right. What's wrong with you? Ah, yes, at ij. Let's do a debug print. And debug print will be something like for I in 0 to m, for j in 0 to n, you print ln, just a print what number of realities at ij. Oh, yeah, let's move it here, and then it print ln nothing. Realities. What's on here? Yeah, can we move it? No. Parse 2. Okay, yes. Let's 2. Solve 2 should be 40. Okay, let's run it. Ah, yes. Mutable. Yes, canon power is mutable. Definitely. I agree. Let's go on. Unused variable. It's just a warning. And this is again an error. Okay. Problems. Cannot mutate immutable because yes, it must be mute. Unused variable I. Rust. Why are you so pedantic? So 1 defined here. Not find value n in this scope. Yes, you are absolutely correct. Yes. And now propagate should take n and n. Yes, structures. A structure is helpful here, but I will not be refactoring that into a structure. Yeah, what's wrong with you now? This function takes 4 parameters. I agree. I completely agree. Now shut up. Okay. You might meant pattern match on a similarly named. What do you mean? Ah, I see. But yeah, that was just being pedantic. Yes. Will you run now, please? Panicked. Root cell 10. Oh, yes. Somehow I got addressing wrong. Bad cell. Okay. So that means what? Where does this J come from? Oh, okay. Mm. Mm-hmm. 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 What was the position? Panicked. It actually panicked in backpropagation. Okay, that's fine. Yeah, that points to something that really went wrong. Let's say realities. U64. Also MNN. Oh, come on. Reslan. Print realities here. And print realities here. Let's run realities. So it filled this reality, but and then failed. And unreachable code. So then in here. Why? Oh, because yes, it must be n. Yes. Wait. Okay. Oh. Let's try to do that. What the hell? Is it even a correct U64? I hope so. So yeah, my intuition that I have to use U64 was correct. Yes.